Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here and it's our final video on simultaneous equations and we're solving them from the context of a problem. Please make sure you've watched all the previous skills and videos on simultaneous equations in order to access this video. Right, I'm going to go back to the very first puzzle I set you to introduce the idea of simultaneous equations. Remember the puzzle? 5 t-shirts and a hat cost £22, 2 t-shirts and a hat cost £10. How much does a t-shirt cost? How much does a hat cost? I want you to form a simultaneous equation for that puzzle above. Well, I did this when I first introduced it. I said, you want to work out how much a t-shirt costs. You don't know how much it costs. Call it a letter. Why don't you call it X? You want to know how much a hat costs. Give it a letter, an unknown variable, call it Y. And then what we're going to do is we're going to set up and form two equations from the information. We're given one piece of information here and a second piece. We're told 5 t-shirts and a hat cost £22. So we could say that 5 times x, 5 x's, plus a y must equal 22. And we're then told 2 t-shirts and a hat cost £10. So we've got 2x add y is equal to 10. And we would solve that. So solving this is equivalent to solving this puzzle here. And that skill there, converting some sort of paragraph or text into some simultaneous equations, is a useful skill and something I'm going to show you a couple of examples of to show you a real world in context use of simultaneous equations. The key really is to label something x, an unknown x, and label another unknown y, and then go back to the question and use the facts it gives you to set up two equations with your x's and your y's, and then you can solve them using elimination usually. Right, let's give it a go in a couple of cases. It says find two numbers with a sum of 15 and a difference of 4. Now, sum means when you add them together. Difference, we should know, means when you subtract them. Now, we don't know the two numbers, so we better state we're going to call them something. So let the two numbers be x and y. Why not? Call them x and y. It's as good as anything. Could call them A and B if you want, C and D, P and Q, Bob and Jim, but let's just call them x and y for the sake of it. Now it says the sum of the two numbers is 15. So we can use that fact to say that x add y must equal 15. That's pretty easy, isn't it? And it says the difference of the two numbers is 4. So let's just assume x is the bigger one. It doesn't matter. We could say that x subtract y must be 4. And oh look, we've got ourselves two simultaneous equations. Call them 1 and 2. How am I going to solve them? Elimination is usually our best bet. We have got the same number of x's here, and we've got the same number of y's here. We've got 1 and 1, but there's a negative. Now we could either subtract the equations to eliminate x, or we could add the equations to eliminate y, because all the coefficients are the same. It doesn't matter. I think I'm just going to add them. I'm going to add these equations. X add x is 2x. Y add negative y is nothing. I've chosen to eliminate the y. I could have subtracted these guys and eliminated the x. You'd get the same answer. 15 add 4 is equal to 19. So divide both sides by 2, and I will get myself x is therefore equal to 19 over 2. Leave it as an improper fraction, it's fine. Now I need to get myself y, so I'm going to sub x is 19 over 2 into, let's say, equation 1. And what would I get? Well, I'd get 19 over 2 add y is equal to 15. I'm going to subtract 19 over 2 from both sides. So I'm going to subtract 19 over 2 from there and 19 over 2 from there. I better go up here to continue my work. And I would get myself, therefore, that y is going to be 15 subtract 19 over 2. Now that's really 15 over 1. To subtract fractions, I need to make the denominators the same. I'll double that, and so I'll double that. So y is going to be 30 over 2 subtract 19 over 2, which is actually going to be 11 over 2. And so our answer to this problem is x is 19 over 2 and y is equal to 11 over 2, and we're done. Now sometimes it's helpful for us to think of it as a decimal. We'll usually write the answer as improper. Just to think of it as a decimal, 19 over 2, half of 19 is equal to 9.5, and half of 11 is equal to 5.5, right? Now, is it true that if you add these numbers up you get 15, and if you take them away you get 4? That add that is 15, that take away that is 4. Yep, I found the right numbers. But leaving them as improper is the way we usually do it. And we're done. We solved this problem using simultaneous equations. Let's try another one. 30 tickets were sold for a school play. Child tickets were 60p, adult tickets were £1. In total, £22 was raised. How much of each type of ticket was sold? Right, let's start by giving a variable here. Let's say let x equals number of child tickets. Okay, let's say let y equals the number of adult tickets. Okay, now we know one fact from up here. We know the following. We know 30 tickets were sold for the school play, so the number of child tickets added to the number of adult tickets must be 30. So that's one fact we can state. I'm going to even write it here. X add y must be 30. The number of child tickets added to the number of adult tickets is 30 from that fact here. Now we're also told that the child tickets sell for 60p and the adult tickets sell for £1, and in total £22 were sold. There's another fact we can get from that. There's another equation we're going to be able to write down from this information here. Now let me explain. Just imagine I told you 10 child tickets were sold and they were 60p each. How much were they raised? Well, you would do 10 times 0.60, wouldn't you? If I told you 20 child tickets were sold, how much would you work out was raised? You'd do 20 times 0.60. Now I'm telling you X tickets were sold. So what would you do? Well, you do X times 0.60, which a mathematician writes as 0.6x, like that. So that's the amount raised from child tickets. So we can say that 0.6x. Now let's do the same with adult tickets. If I told you 10 adult tickets were sold, you would do 10 multiplied by £1 each, wouldn't you? And you would say that's 10. If I told you 20 were sold, you do 20 multiplied by £1 is 20. I'm telling you y were sold, you do y multiplied by £1, y multiplied by 1, you just get y. So you would add y, that's the amount you get from selling the adult tickets, and you are told that the total raised from the child tickets and the adult tickets is £22. There you go, we've got our two simultaneous equations. Look at them and see if any of the coefficients are the same. Yep, happy days, these two are the same. So I can take equation 1 and subtract equation 2 from it using my technique of elimination. Now, 1x take away 0.6x. 1 take away 0.6 is 0.4. So 1x take away 0.6x is 0.4x. And that's going to be equal to 30 take away 22, which is 8. Divide both sides by 0.4. So x is therefore equal to 8 divided by 0.4. Now we've done this when dividing by decimals before. I don't like dividing by decimal, so I'm going to use the equivalent fractions. I'm going to multiply the top and bottom by 10 to help me work it out. That's like 80 over 4, which is 20. So therefore x is equal to 20. And if I put 20 in here, 20 add what is 30, y is equal to 10. And there you go, we have solved the problem. X is 20, y is 10. So the number of child tickets, we'll just state child, I'll just say times 20 tickets, and I'll say adult times 10 tickets. And we have found the answer to that problem. Now before we go on, you really should check your answer and check it works in the context. 30 tickets are sold. Well, 20 tickets add 10 tickets gives us the 30 tickets. It seems to match that criteria. And the next thing you could say is the child tickets were 60p each, so 20 times 60p is £12, and 10 lots of £1 tickets would be £10, so £12 at £10 gives us the £22. So indeed it seems we found the right answer. So that's basically it for this video. We're going to use simultaneous equations a lot in context in geometry coming up. So there is a little extra bit of work for you. In the printout PDF at the bottom, you can try a geometry question in advance if you would like to, a simultaneous equation on that. But we'll come back to these type of questions in the geometry. But for now, as long as you know the basic skills and how to solve a simultaneous equation in context, you'll be fine. Thanks for watching.